Good afternoon, everyone. Welcome back. I'm Steve,
And I'm Scott.
and together we're Backyard Musings. I'm still at Legoland.
And I'm back in California, but we're not together. Steve's at Legoland, and I was banned from Legoland years ago. So,
Humbug.
and if you're trying to figure out what his backdrop is, it is a shower curtain.
Yes, I'm in the bathroom still. There's no table out here in chair, so I'm on the counter in the bathroom.
Yeah,
All right.
who needs a table and chair? So,
In the
okay,
world, and also because hotel Wi-Fi is sketchy, I'm tethered to my phone. Really weird.
giving away all your secrets.
Yeah, I know. In a world of quantum physics, the rules that govern reality behave in ways that challenge what we think we know. Particles can be in two places at once.
How is
Actions
that
on one
possible?
particle can instantly affect another, even across vast distances. Teleportation isn't science fiction, it's part of how the universe really works at the tiniest level. Now, researchers have added something even stranger than a mix: quantum time travel. Not time machines in the classic sci fi sense, Back to the Future. Instead, this is a breakthrough in controlling time with quantum systems. Particles so small that regular physics barely applies. A group of scientists from Austria has shown that you can speed up, slow down, and even reverse the age of these particles, effectively rewinding time for them. Would you like to know more?
How is that possible that a particle can be in two places at once? I don't.
And that's Schrodinger's cat.
That's crazy.
It can. Yep.
At the center of this work is a clever device called a quantum switch. Think of it as a remote control for quantum particles. While traditional physics moves like a movie in a theater, playing from start to finish no matter what, quantum systems behave more like watching a movie at home where you can fast forward, rewind, or skip scenes altogether. Miguel Navascues from the Austrian Academy of Sciences compared it to having control over time itself. That's scary. Quote, if we can rewind to a previous scene or skip several scenes ahead, he said this is not just theory. Together with University of Vienna physicist Philip Walter, Navascues and colleagues used photons, particles of light, to test their ideas. Now we're starting to mess like you just mentioned, Back to the Future, where who was that? The guy that was he was going to the future and finding out who
Marty
won.
McFly. Marty McFly.
Yeah, and he won. Well, no. The guy that went into the future, the bad guy that went into the future and was able to find out results of sporting
Oh, yeah,
events.
that's Biff.
Come back.
Biff, yeah.
Yeah. So, yeah, this is crazy.
But I'm going to posture a theory here. This might blow your mind. But you know how Heavenly Father has given visions to like Moses to show him the beginning of the world, and Moses wrote about the beginning of the world. And you know how Nephi was shown the destruction of his people. So Heavenly Father can do this, so that means it can be done. We just don't have that power to do that now. We're just realizing it. We're just in a small little sense we're realizing, but it can be done.
Yeah, but one thing, like you mentioned though, and I'm not trying to get off on a uh, would it be a theological, not theological, oh maybe religious tangent. He does that through his prophets.
Right.
He doesn't give that power to somebody
Off the
like
street.
me,
Right.
who's gonna, because I'm a man of the world, I'm gonna do something dastardly with it. Where a prophet, they'll be gone if they mess that up. So,
Yeah,
I
the
mean, even
prophet
our
tells the people. Yeah.
yeah. So yeah. Anyway,
Yeah.
but yeah,
Okay.
I get what you're talking about.
Yeah. Using crystals and a setup based on the quantum switch, they sent. Oh, let me show I'm sorry. Let me show you the screen here. There we go. All right. There's the flux capacitor.
Yeah, that's Steve's garage.
Using crystals and a setup based on the quantum switch, they sent a photon on a journey. then use the switch to bring it back to the state it was in before the trip began. This may sound simple, but in the world of quantum mechanics, it's revolutionary. Normally, just observing a quantum system causes it to change. That's what makes this discovery so remarkable. They were able to rewind the system without knowing anything about what happened to it.
Yeah, that's Steve's garage. That's Steve and I in there. We just received that from Amazon, and we were making sure that
Yeah.
it was put together
And,
right.
and I'm the girl.
This method, called a rewind protocol, lets any quantum particle, like an electron or photon, go back to a previous state, even if the experimenter doesn't know what that state was or how it got there. Which means obviously they don't know what they're doing, right? Kind of like
Yeah,
me.
yeah.
David, either is it Trillo or Trio, another researcher from the Austrian team, helped show that the process works in both theory and in the lab. The result was clear. The photon returned to its original state, like hitting rewind on a video without ever watching it. Okay, spooky stuff.
The team also went beyond rewinding. They found that you can fast forward time too. Quote, to make a system age 10 years in 1 year, Navascues explained, you must get the other 9 years from somewhere. In one experiment, they used 10 identical systems by stealing 1 year of aging from each of the first nine. They gave all 9 years to the 10th system, which aged 10 years in just one.
Okay. These discoveries won't let anyone travel back in time or undo mistakes in real life. A human body holds massive amounts of information, and it would take millions of years to rewind even 1 second of someone's life. But that's maybe not everyone's, but anyway. But that's not the point. The goal is to make quantum processors more powerful and reliable. In quantum computers, which store data in tiny, delicate particles, errors can creep in easily. If you could rewind the system and correct the error, you'd save time and energy.
Yeah, so this tells you exactly Heavenly Father, who's omnipotent, can do this. He can actually unwind all millions of particles in order to show you the future or show you the past.
Yeah.
Okay, let me go to slide 2 here. That's the flux capacitor, the complicated circuits on the back of that DeLorean that they built, or the front. Experimental setup. Yep, this is a pulsed TI sapphire laser pumps a spontaneous parametric down conversion source to generate pairs of single photons in a type 2 process using a PPKTP crystal, top left.
Quote, we are convinced that it has technological applications, says Walther. For example, going on with a quote, a rewind protocol in quantum processors can be used to reverse unwanted errors or developments. Other team members added the future versions could be built using systems beyond just light and even expanded to more complex setups.
Now imagine this. What if you could use it in a military application where you could fast forward and see what the enemy is going to do and be right there to counter them? That would be...
Again, this is kind of like, this is almost to the mocking point, right? This is where I think I don't know, we're getting to a point where we're doing stuff that I don't think we were meant to do, but maybe so. I don't know. If we're doing it, obviously, what do we say? The time is right. You know, it's like cell phones or computers or whatever advancement we've seen in the last 25, 30 years. It's being allowed to happen. So, but opposition in all things.
Yep.
So
normally time only flows forward. This arrow of time, first described by astronomer Arthur Eddington, follows the second law of thermodynamics, which says things naturally become more disordered. But this law is statistical. It applies to big systems, not necessarily the smallest ones.
yeah, and I'm probably thinking on the small basis. So in classical physics, it's possible to reverse some processes using a trick called phase conjugation. But in quantum mechanics, random noise usually gets in the way. That's why scientists have long wondered, can you reverse time for a quantum system without knowing anything about it?
Several past studies tried to answer that, but they only worked some of the time and required detailed knowledge of the system or slow, complex procedures. This new protocol is different. It works for any two-level system known as a qubit, has a high success rate, and runs in real time. That means if you rewind a system by 5 minutes, it actually takes 5 minutes.
At the heart of this method lies a key idea from quantum mechanics, the non-commuting nature of quantum operators. This just means the order in which you apply operations matters, unlike in normal math. Using that principle, the scientists create a setup where the target system evolves in superposition, a mix of different timelines.
Each timeline includes slight changes caused by known physical interactions. By cleverly interfering these timelines, they guided the particle back to a previous state, no matter what path it took. And if something went wrong, they could try again using error correction, boosting the odds of success.
I mean, what could go wrong?
Yeah.
The setup used light particles manipulated by half and quarter wave plates to generate different Hamiltonians. Rules that define how the particle evolves in time. Then, using fast optical switches and the quantum switch, they mix the time paths together to create the rewind effect.
They're explaining this in layman's terms. I bet you it's way more complicated.
You think?
These results are more than just an idea on paper. The team tested their method on many different quantum processes and reached a rewind accuracy of 95%. That level of control opens the door to using quantum time reversal in real-world technologies.
The rewind particle could help develop better quantum computers and new ways to control quantum states in labs. It could even offer insights into how time works in the deepest parts of physics. Still, novice Q's stays realistic. Quote, if we could lock a person in a box with zero external influences, it would be theoretically possible to rewind them, he said. Again, quote, but with our current protocols, the probability of success would be very, very low.
That's because of so many molecules, yeah. In other words, it's not time travel as you know it, but it's the closest thing physics has come to bending the clock backward.
Yeah, I don't know.
Mind-blowing.
It's weird. Yeah, this is weird stuff. So even for my simple mind. But,
weird science.
Yep. Anyway.
All right, folks. Thanks for joining us. I hope you enjoy your Sabbath, and we'll catch you on Monday.
Yep. Take care, everyone. Enjoy the rest of your weekend, and let's hope that Steve can get out of the bathroom. So take care. Thank you.